All right, guys, we're going to find zeros again. Remember, the zero of a polynomial is an x value that will make y 0. So we're going to make y 0, and then we want to factor the polynomial. Now, the first thing we always look for is a greatest common factor. The only problem is, in this polynomial, there is no greatest common factor. Because easy way to think about this is 5 and 7 are both prime numbers, which means that there's no factors except themselves and 1. So there's no way that I'm going to find a common factor between these three terms. The other thing that you need to look for is see if you can take out an x value, if there's a common factor of x. So the only issue with that is the last term doesn't have an x in it either. So x is not a common factor. So absolutely no common factors. So how do we factor this if there's no common factors? Well, after you try to find the greatest common factor, you got to look at how many terms there are. And since there are 3 terms, the only option we have left to us is A times C method. A times C method. So again, my A is the 5, my B is the 7, and my C is negative 6. So if I take A times C, that's going to be 5 times negative 6. 5 times negative 6 is negative 30. And I want to find factors of negative 30 that add up to positive 7. Why? Because positive 7 is my B. So let's start with the easy, obvious one. 1 is always a factor. If 1's a factor, the other factor would be negative 30. What about 2? 2 is a factor. The other factor would be negative 15. 3 is a factor. The other factor would be negative 10. 4 is not a factor. 5 is a factor. 5 is a factor, and the other factor would be negative 6. Then I got 6 and negative 5, 3 and 10 and negative 3, 15 and negative 2, and 30 and negative 1. Now, the question is, which of those factored pairs adds up to be positive 7? Well, I can look through them all, and I notice that 10 plus a negative 3, which really we could think of that as being minus 3, is going to equal positive 7. So 10 and negative 3 are the pair that I want. So what I'm going to do is I'm going to take this polynomial, and as part of the factoring process, I'm going to rewrite it with 4 terms instead of 3. And the way I'm going to do that, I'm going to keep my first term. I'm going to keep my last term, but my middle term, I'm going to split it into 2. And the way I'm going to split it into 2 is I'm going to take the 7x's that are right here and write them as 10x over here minus 3x. How did I choose to split 7 up into 10 and negative 3? Well, it's because of this pair that I found. That's the whole point of finding the pair, is to write this as 4 terms instead of just 3. So now what I'm going to do is I'm going to take the first 2 terms, 5x squared and 10x. I'm going to take the GCF out of that. So GCF of that is going to be 5 times x. And if I take a 5x out of the first term, I'm going to have an x left behind. And if I take a 5x divided 5x out of 10x, I'm going to have positive 2 left. Now I'm going to look at those second 2 terms. What comes out of negative 3x and negative 6? I think negative 3 would be my greatest common factor there. And if I take a negative 3 out, I'm going to have x plus 2 left behind. So there's my, well, I'm not quite done factoring yet, but there's my next step. So my last step is going to be take that matching parentheses and divide it to the outside. Divide it to the outside. If I divide 5x times x plus 2 by x plus 2, I'm going to have 5x left. And if I divide negative 3 times x plus 2 by x plus 2, I'm going to have a negative 3 left. And there's my factors. Look at that. So now what can I do? I've got 2 factors multiplied together that equal 0. So I've got 2 options. Either my first factor can equal 0, or my second factor can equal 0. If my first factor equals 0, then x would have to equal negative 2. And if my second factor were to equal 0, then my x would have to equal, let's add 3 to both sides, get 5x is equal to 3, and then divide both sides by 5 so that 5's cancel, leaving the x all alone to equal 3/5. So what are my zeros? My zeros are -2 and 3/5. So the key here, what made this different than the other finding zeros problems, is that I had to find the greatest common factor here, leaving behind 2 zeros. Not the greatest common factor. I'll edit that out.